And today we'll have the first keynote will be Susanna Assunta Sansone, who is the honorary academic editor of Scientific Data. It's a new publication from the Nature Publishing Group focused on publishing data. And she's also associate director and principal investigator of the Oxford E-Research Center. So she traveled a long distance to be here with us. And please welcome Susanna.
So first of all, thank you very much to Lucille and everybody else to invite me here. It's a great pleasure. So yes, I am both an associate director at the Oxford University, so that's where my main activity are. But in the same time, I'll try also to cover, the importance of the role of the publisher in these data-centric enterprises. Oops. Right. So, Love Your Data and Practice Safe Science is the title of this infographic by Digital Sciences, which actually helps me to introduce the topic of my presentation, or rather the problem I'm trying to address, and problem which you are very familiar with, I'm sure. So there is a growing data output, and apparently 30% annually in scientific data. There is a lot of investment in actually manage the data, but despite that, it's very clear to everybody that not all the data is really reusable or easily accessible or actually managed in the proper way to be reused in further investigation, or sometimes even to be evaluated. And so this is a critical problem, particularly for data that enter, clinical trial. You need to have trust and faith in the data. So you need to be able to reuse it and verifying it. And there is also an increased number of retraction, which, we're probably very familiar with. And this is actually highlight a big underlying problem in data management. And there is also time and effort that researchers spend in the manipulate data set, reformat it, restructure it, using new terminology, ontology, mapping it, so that we can integrate the data and reuse in a certain context. And all this it's also cause of errors which are introduced and should not be the case. Of course, funders know the problem, so we do. So the data scientists, that we all trying to do our best. And funders, as you know, have strengthened their data management, their data stewardship, their data sharing policy. And this is actually happening worldwide. So there are many movements that are trying to practice safe science, or developing tool and standard that enable scientists to practice safe science. And I want to mention one in particular, which is called the Data Fairport. So this was initiated by Barendmont in Netherlands as part of the Netherlands Elixir node. And I don't know if you are familiar with Elixir, coming from Europe. I'd rather spend a couple of words. So Elixir, it's a pan-European entity, infrastructure, to aiming to develop sustainable bioinformatic infrastructure. And it's closely working also with NIH and other, worldwide funders, because it's very important that this data infrastructure are all compliant and connected to each other. So the Data Fairport is also a joint effort with the Force 11 group, which actually Maria Martin leads. And it's a really important group of people trying to promote the idea of data publication and data sharing. So there is like a big synergy behind this Data Fairport concept. So what actually FAIR means, it's an acronym, quite nice one, which means data need to be fundable, so the importance of identifying information. And this is probably very trivial information for you, but it's important that there is an high-level concept that unify, the different activity. Data need to be accessible. Doesn't mean to need to be open, because, of course, in the context of medical data and the privacy, like Lucilla just mentioned before, you need to manage the access to certain data or element in the data. Data need to be interoperable, of course, and need to be reusable. So the machine-readable formats, all the ontology, all the structure, all the standard are key to this. But this is not something that just the Fairport group says. This is very much aligned with the NIH Big Data Technology Initiative and the concept of the NIH Commons. So I'm just taking the slide from the latest ANTS meeting, where actually, as you can see, the idea of the commons is really to make the data accessible, fundable, interoperable. It's very much what everybody says. So this is actually very true, and I very much support this concept. In fact, in the last 14 years, that's what I have been doing as well. I've been doing my fair share of work towards fair data. So I've been working with a researcher. So I am a biologist by training, became a data scientist when I joined in 2002 the European Bioinformatics Institute. So I work with other people's data, help them to make them available and reusable to others. I also work with curators and with developers because they play an important role in supporting the researcher to make this data available. And I also work with funders and journals very recently because they all are important stakeholders and they all need to be engaged. So there is a lot of social engineering also that need to be done on top of the technicality of making this data fair. So what I personally I've been doing in particular, focus on increasing the level of annotation, the level of description in basic biological research data, which can be used also in a clinical context potentially, and particularly helping researchers to put down as much information as they were aware of the experiment that has been conducted, and help the curator and develop standards and tools that structure this data so that the data contain the provenance of the information. It's machine readable and can be consumed by tools in an high throughput manner. Well, let me try to give an example of what really this means, in particular what my interest and focus is, which will be the topic of my presentation. So in order to make a data set fair, you need to have the standards, the tool, the best practice that helps to tease out the key detail in an experimental step, the key feature of the experimental workflow, of the samples, the treatment, of the data processing, of the tool use, of the software, and etc. Make all this structured so that it's understandable by somebody else, regulate the access, and so on and so forth. This graphic is just a toxicogenomics experiment. It's quite typical experiment we have been working with, where you have several samples treated at with different dose at different time, different bio samples were taken from the animal, there were different tests done, and etc. So it's an information-intensive experiment, and like many others. To me, the key part of making the data fair, the stepping stone, the starting point, is to have enough information. So the breadth and the depth of the description of the experimental step, to me, is pivotal, because if we don't have that, we can make everything machine readable, but we need to have the content and the context of the data. So I've always been focusing on making sure that there is enough experimental description, which is reported. All the sample characteristics are very well described, and of course, depending on the sample that you're using, certain characteristics are more important than others. The experimental variable, the intentional variable, are explicitly recorded, so the technology, what software was used, what version was used, what protocol, what analytical workflow was used, is the analytical workflow available, can I reproduce it, etc. These are key information to make the data reusable. Now, of course, to make sure that my description of the experiment fits your description of the experiment so that we can correlate, compare, integrate the data, we need to have common ways to report this experimental context. And that's why the role of content and reported standard is something I want to highlight. Of course, there are different types of standards, standard for defined identifiers and etc. But I want to focus on these three types of standard, which is the one I really work most on, which are guidelines, terminology, and format. So what are they? Let's try to go in a little bit more detail. So guidelines is something which has been developed by many people and also is known as minimum reporting requirement or checklist. In a clinical setting, it's CONSORT, for example, or in a macro experiment is the famous Miami checklist, in 2001 published, which reports, the minimal information that need to be described for someone else to understand the experiment. What characteristic of the sample, depending on the type of sample, what are the steps that need to be recorded, which are important in the evaluation and reuse of the data. The terminology, it's like a big bag which includes control vocabulary, thesaurus, more rich ontology, because there is a variety of those terminology out there. They are not at the same semantic richness, they don't have the same formality, but they are very important because we need to use the same words and mean the same thing when we describe certain element in an experiment. But of course, the third element of this content standard is the format, because once I've reported information, I've explicitly express a certain term, I want to then make sure that all this description is available in a machine-readable format. So under format, I include exchange format, but also conceptual model, conceptual schema that enable this automatic exchange between tools, software, databases. So these are what I defined as a content standard, which is going to be the theme of my presentation. There are many groups which have and are developing reporting and content standard. These are just few. It doesn't tend to be an extensive list because there are really, really many groups out there. I always present them, divide them in two groups. On this side, on the left-hand side, there are those more proper standard organization like CDISC, for the Clinical Data Exchange Consortium, the HL7, and many other. On the right-hand side, there are more grassroots initiatives. So these are sometimes a legal entity, sometimes are not. Sometimes are, formalized groups, sometimes are more fluid groups that merge with other. But they still have developed standards which have become de facto standard in their community. And those particularly are groups in the omics area. That's the area I operate most. So Genomic Standard Consortium, Proteomics Standard Consortium, combined, which covers system biology. There is the RDA, the Research Data Alliance, which actually is a really broader, but also has some activity in the bio area in developing this kind of standard, and many other. Now, these groups are very different, sometimes from the operational point of view and the structure point of view. The grassroots initiative, particular, are volunteer effort. There aren't core funds to do the activity, and sometimes they have formalized process for releasing and updated standards, sometimes they don't. So understanding how do they operate, how do they formulate, create, and maintain the standard, and what has worked in this group and what hasn't worked, has been actually the topic of a workshop organized by Mark Huerta and Leslie there at the NIH last year, to understand, because big data, the NIH Big Data to Knowledge Initiative plans to fund standard activity, but of course, they're very intensive activity. You can't find everything, but you need to understand where this group requires support and in which phase the support and the funds are most needed to make sure that these community standards are widely accepted and actually enable the data sharing, because standards are just enabler of data sharing. The big problem with all this content standard, it's the fragmentation. What actually means, I'll give you some number afterwards. I mean, you realize a sense of the wealth of standards which are out there, content standard. But the point is, this group, which I mentioned before, and all the other that exists, come to develop standard from a different viewpoint. Some groups come together because they work on plant science, or because they work on patient data, or because they come from the macroarray technology group, or they're doing proteomics. So really depends the approach and the way a standard is defined. So a checklist is created or an ontology is created. Sometimes it's very application driven and it's focused on a certain area, which is good because you need the expert in the area, you need the use cases, you need the competency question that drive the development of a usable standard. But it's also important that standard they use in combination, because here we talk about combining data from different domains, basic data with clinical data with environmental data. You don't want the standard to be fragmented, so they create silo data, which then we need to reformat to try to merge together. ideally there should be some, they should work like Lego pieces, that you can use the right Lego pieces to create the building blocks you need. It's very nice wishful thought, but that's not the case. So let's look at the number here. So there, in terms of content standard, reporting the standard, it's over 500, I count. There are over 300 terminology. If you look at the bioportal from the NCBO, over 300 terminology covering biology and biomedical area. There are over 70 guidelines from the biomedical and the basic research, and around 150 format. And here I'm not talking PDF as a format, but I'm talking the format to report the experimental steps and the associated data file. So it's a large number. And the point is there is a number of databases that could store this data in this format or using this standard. And there is a number of tools which could help researcher to create data using this standard. But all this, it's an unidentified number of, and we need to try to map this landscape to really understand if those standards are useful, who is implementing them, how can they be supported, how they can be reused, and so on and so forth. So this slide here is just a lot of question mark. So this is the problem that my collaborator, I'm sure you face as well. The point is we need to really help researcher to understand that it's important to report in a rich amount of information. They need to be aware of this standard. But standards are not for them. Standards need to be used by developers, so need to be implemented in tool, need to be used by curator. Standards are a complicated thing the researcher doesn't want to know. I believe standards need to be made invisible to the users. So they need to be implemented. The user need to be able to follow. They need to be aware that they need to provide enough information and follow the information that either she or he has been asked to give. But important is to develop tools that make the standard invisible. The question is, standard, it's never complete. It never fits everybody. So they need to be somehow extended. They need to be somehow modified. So it's important to explain how they can be extended. And most of the standards do not have the right legal framework for extending, for giving reward, for giving, the freedom to create branches. It's not there yet. Also, funders and journals need to have guidance on which standard they need to recommend. Which database should they recommend? Because they know that the database implements the standard. Therefore, the data in that database will be richer description and perhaps more usable. But they don't know what to recommend. And they are yet developing guidance to author and ORD. And sometimes if you read the reference to standard, it's really vague. It's about use the most appropriate standard for your domain. Now, the question is, what is the most appropriate standard? What's the most valuable and mature standard that a person needs to use? Okay, so to address now a lot of problems, let's try to show what we have done, trying to solve or at least to tackle the issue. I created in 2011, and now with a larger group, we are promoting the biosharing as a common registry. It's a web-based curated registry of standard, and we aim trying to list all this content standard, make them informative, make them discoverable, so that you can monitor their use, you can see who is doing what, in which area those standards are applicable. So the idea is really to map this landscape of standard in the broader life science area, and also trying to link them to databases where those are implemented by databases, and to policy when and if they will be recommended by a policy. So the goal overall of biosharing is to assist the stakeholders, which were in that nice picture earlier, and which are researcher, developer, curator, funder, journal, and editor and librarians, to make the decision they had to make on the standard, which you want to use, which you want to implement, which you want to recommend, how can they be extended, who should they contact? Basic questions, which at the moment are hard to answer. We're not doing this alone because it's impossible. So although my team in Oxford, which is a very small team, it's the operational team behind this, and this is actually our side activity, not even our main activity. We are working with an advisory board, and we have just created a working group under the Research Data Alliance trying to outreach more people. There are lots of journals involved and progressive number of funders because they're interested in understanding what standard to recommend, but also a lot of scientists which are also users of the standard, contributor to the standard. I want to particularly acknowledge Jess Tenenborough and Melissa Handel, which have kindly accepted to co-chair the advisory board. So in terms of content, what we have now, what's there, and what we are doing next, very quickly. So we currently listing and registering 500 content standards, as I mentioned before. For the terminology, we are linking to the bioportal, and we will progressively work more with the bioportal, and I'll tell you how later. We have recorded more than 600 databases. Of course, you know, there are 1,000 databases out there, but we are working to do this systematically with, particular with the NAR database issue and the database journal part of the Oxford University Press, because that's where authors describe the databases, and at the same time we ask the author to claim or update or enter a record of their databases in biosharing and link into the standard where a standard is used. Because, of course, they are the ones who know best if a standard is used. Sometimes you can't find it from a website or the database. Current functionality, you can go on the biosharing, you can start querying, searching, claim certain record if the record belongs to you, because maintaining a record update in any registry, it's one of the hardest things to do. We link to ORCID and etc. And we are doing and continue to do a lot of things, because registering and cataloging the standard, it's only the first step. Then you need to do a lot of work, particularly how you assess the criteria for using the standard and their popularity, their maturity. So this is something that myself, Jessie, and Melissa actually started and tried to explain in this paper on JMIA actually early this year. There is a sea of standard, and at the moment we are really drowning into standard. We aren't swimming at all. So we need to try to understand what are the objective quality criteria to mark this standard. So biosharing will not recommend the standard. We will create quality metrics which will be associated to the standard. According to your criteria of selection, you will decide what the recommendation will be. One of the other things to do, which is very important, let me remove the animation here, it's that we also need to link to standards, policy, to databases. We need to make everything fully searchable. We are embedding biosharing into an ecosystem of existing registry, because it is a lot of related things we need to link to tools, to more publication, to people, and there are other registries out there. We are fully aware we're not trying to invent things. That's why we're working with Elixir broadly, with the RDA, with the bioportal, and with Atrix, which is a biomedical infrastructure, translation infrastructure, private-public partnership in Europe, which help us to link with the biomedical area, because CDISC, it's one of the partners in this project. But we're very well aware that also the NIH plans to map this landscape of standard. In fact, you might be aware that there is a request for information out there right now, which closes at the end of this month. And we will respond as biosharing. We're working also with existing people. So we hope that biosharing can be included in this wider context of registry, which will help the NIH to make certain decisions around standard. And I'll expand on the relation with the NIH at the end in a couple of slides. Okay, so just step back 1 second. The reason why I explain why standards, reporting standard, the content standard are important, it's because they are enablers. They enable scientists to describe a certain rich experimental step so that can be reused and can be understood. But of course, to do that, they need tools. And tools need to be able to implement the standard and make the standard invisible to the user. So that's my primary activity. In reality, biosharing was a bioproduct of what we have been doing since 2007, which has developed this set of tools. And here I'm not presenting them to advertise them, but explain how complex it is when you try to implement this standard in a set of tools, particularly if your tools are general enough, and they try to cope with the toxicological data, environmental data, different type of sample, different type of technology, because as I said before, the standard are scattered and cover different domains. So you have to be able to twist and tune your curation tool, your data capturing tool, to capture certain descriptor if you're using a rat, or another descriptor if you're taking a cup of water from a lake, because there are different descriptors which are needed, different ontology, and so on and so forth. So how you create customizable tools that fit to the different standard requirement yet hide the complexity is really tricky. So anyway, since 2007, because I work with different data type and community, we created the concept of, I'm not sure why these headers pop up, but I don't want to click. Oh, that's it. It's gone. So we've developed the concept of the ISA, which it's both a set of tools now and an underlying format, which is customizable, generalizable to try to fit to the different minimal requirement and using different ontology depending on the type of experiment you are doing. Now, I'm showing very, very quickly what the ISA means, because it's actually related to also the data publication concept afterwards. As I said, it's a general purpose, configurable format, lightweight format to describe the experimental steps. The idea is to track the provenance of the information, the experimental context, which is my focus, follow the community requirements using certain ontology, but we are very cautious that there are other formats which are used in other areas, like the CDISC standard are used in a certain clinical setting. So we make reference system to other files where like the SDTM in this case, where other information is connected. This is true because there is no true interoperability among the standard, but at least having a reference system, a way to connect those different data files is the best way to go. It's also we designed it with collaborators to be able to convert to other metadata formats like those at the time required by the EBI repository, because I was at EBI when we started this project, but also by NCBI and other general omics repository, although this is not just for omics data. It's a tabular format because that's how we decided. There was an agreement to start for a tabular format, but there is also an RDF version. So we are actually approaching the concept of linked data, and the data is available also in RDF as a format. There are different conversion formats. So having a format, even if it's configurable to this checklist and to this ontology, and yet is really, really complicated, can only be done if you have tools that enable that. That's why Step 1 was developing the format. Step 2 was in collaboration with our collaborator and user and different projects throughout the year. We created a suite of tools which help user in the different steps, help them in describing the experimental step following the standard. Now, this is the tricky part. In order to follow the standard, you have to use a certain tool which is called configuration tool, which is not easy to use because you need to know which ontology best work for your characteristic of the sample, which ontology is more appropriate for the instrument description, which ontology is more appropriate for the data flow, and you don't know that. So we actually realized that over the year, time is up. Okay. Well then, the only thing I can do is to skip my last part of the presentation. I didn't realize I went over. Do you give me a couple of minutes? You tell me. I'm happy to. A couple of minutes. Okay. So I have only one slide and one slide for the data publication, which I didn't realize. So we are now working to embed both biosharing and ISA into more NIH activity. Now, all I'm saying here, it's pending notification of awards. So nothing it's actually been decided. But I talk with Mark Muser, which is the PI of CEDAR, which is a Center for Extended Data Annotation Retrieval, which could be funded under the new NIH Center of Excellence, because the topic, it's really exactly what I've been describing. We're going to research to find better methods to facilitate the use of standards in data annotation, in data retrieval, which is really core. And we also connected with a couple of groups which are part of the data coordinating consortium. So what I really wanted to do in the last part, and I'll only have one slide to do that, it's that publisher have an important role in all of this. So publishers are agents of change, and this is a term which has been used during the NIH ads meeting, actually. What does it mean they are agent of change? It means that the data is now part of the scholarly communication workflow, and the responsibility, it's not only of the researcher, of the funder or the developer, but it's also the responsibility of the publisher, because they occupy a leverage point in this process. And as you know, the number of attraction has really gone up. So it's really important that data review and data publication also, follow the concept of the fair data. So I was meant to also present scientific data, which is actually, it's the new data publication platform by Nature Publishing Group. And the idea is to give credit for sharing the data, credit for reuse the data. It's the data, it's curated in-house by the curator. It's shared as an ISA tab format, stored in-house. And we work with with the databases, community databases to make the link. So I want to show you only one thing, which is very important. It's how scientific data fits into the ecosystem of databases and data resources out there. So at the center, there is scientific data, where the data descriptor, which is the article type, the content type of scientific data, which is focused on describing the experimental step. It's focused on reuse. It's not focused on describing your result or your discovery, but just on explaining all the steps, how you created the experiment, how the data is reusable by somebody else. Will be at the core. We are linking to the paper, there could be a paper associated to the descriptor, and there could not be. And we are linking to the repository, because we are not storing the data, but we are only storing the experimental descriptor as an ISA tab, which will be linked to the different record where the data file are stored into. And that's where the role of biosharing will be also, to decide which databases we are going to recommend and why, because they are sustainable, because they use standard, and etc. And I'm afraid I will have to switch to the last slide, which is just the acknowledgement slide of my team and the founders and the scientific data team. Thank you. Really sorry, the time went.
Well, I apologize because I took some of your minutes too. But I'm sure Susanna will be here today and tomorrow morning to answer any questions that you might have, or by email as well. And it's a fascinating area. It's something that 10 years from now we will say, why didn't we have that? What took us so long to get to that point? So I view iDash as being one such database for human subjects data that has some elements of the data access control in the spirit of having data sharing.